Lesson 33, a topic that we have in this lesson is called product of primes. And you might remember it as prime factorizations, using a factor tree and finding the prime factorization. Well, prime factorization and product of primes really mean the same thing. Now, before we get into this, let's make sure we understand what we mean by prime numbers and composite numbers. So any number you can either categorize as prime or composite. Now, what are prime numbers? Well, prime numbers have exactly two factors. So, for example, 3 is a prime number because the only factors of 3 are 1 and 3. And remember, when we say factors, factors means two numbers you multiply together to get a certain product. So the only factors of 3 are 1 and 3 because 1 times 3 is 3. 5 is prime, 7's prime. Those are just some examples. Now, composite numbers have more than two factors. Not only do they have the factors of 1 in itself, but they have others. So, for example, 4 is composite because not only does it have 1 times 4 or 1 and 4, but it also has 2. 10 is a composite number. 15 is a composite number. And we can keep on going with examples of more composite numbers. Now, let's go back to primes just to make a note on something. 0 and 1 are considered not to be prime nor composite. They're neither. So earlier when I said every number can be categorized as prime or composite, that wasn't entirely true because 0 and 1 are neither. All right, let's go over an example. Let's write 108 as a product of primes. Or in other words, let's write the prime factorization of 108. So we're going to start by using a factor tree, and you're familiar with this. So we start with two factors of 108. And you can pick any factors. Anything will work. Now the first thing I notice is it's an even number, so I know 2 is a factor. So 2 and what would that be, 54? Now 2 I cannot break down. I'm going to circle it because it's prime. I can't break it down. You might say, well, I could break it down to 1 times 2, but I still have 2. Now 54 I can break down to 6 times 9. And I can break down 6 to 2 times 3. And I can break 9 down to 3 times 3. Now, I cannot break down the 2's and 3's because, again, they're prime. We want to make sure that we end up with prime numbers. So I'm circling what I've ended up here with at the end of the branches of this so-called factor tree. So now, what is my product of primes? Well, how many 2's do I have? I have 2 2's times, because again, product means multiply. And then how many 3's do I have? I have 3 of them. So notice that when you're done, you should be multiplying and you should end up with all prime numbers. Notice my bases. The exponents don't need to be prime, but the bases need to be prime. So 2 is prime and 3 is prime. Now these are really easy to check because 2 squared means 2 times 2 and then times 3 times 3 times 3. And if you multiply those together, I do get 108. All right, one more example. Example 2, same thing, right? This is a product of primes. So let's break down 400. Now the first thing I notice, it ends in 2 zeros, so I know that 100 is a factor. So 4 times 100. Now something else you want to make sure that you understand is it doesn't matter how you start the factor tree out. If I start this off with 4 times 100, or say I started it off with 40 times 10, as long as I do it correctly, I'm going to end up with the same answer at the end. Now I'll break 4 down to 2 and 2, and those are primes, so I'm going to circle them. I can break down 100. I could use 10 times 10. I could use 4 times 25. I could use 2 times 50. It doesn't matter. And tens I can certainly break down to 2 and 5, with each of those being prime. And same thing here. So my product of primes then, how many 2's do I have? I have 1, 2, 3, 4. And then times, because again, product, I have 2 5's. Now if I want to check that, I take 2 times 2 times 2 times 2 times 5 times 5, and I certainly would get 400. So, product of primes, or in other words, prime factorization, is the topic, or one of the topics in lesson 33.